Lesson 34, Simultaneous Equations, Example 4. Using the identity matrix, solve simultaneously a plus 4b equals 13 and a minus 5b equals minus 23. Now this assumes you know a little bit about matrices, but even if you don't, you'll probably be able to follow this, okay? Now what we'll do, we'll set this these sets of equations up as a matrix, and we'll do that this way. We'll write this as, we'll take the coefficients of the a's and b's, then it becomes 1, and this is a 4, and I'll just write this 13 here, and this is 1 minus 5 and minus 23. Okay, this should be a bit more curved, strictly speaking. Now, what we'll do here is I'll just draw a little line down here. This is actually called the augmented matrix. Augmented matrix, if you want a name for it. This technique is quite useful. Now, what we do then, we've got, these are called the columns and these are the rows. So this is the first row, we'll call that one row 1. This one is row 2. Now the aim is to change this matrix into the identity matrix. Now the identity matrix is this part here, sorry, the identity matrix is 1, 0, 0, 1. That's the identity matrix. Okay, now to do that, what I'll do is this. First up, I'll change the sign in row 2, so it's a different colour here, minus row 2, and then I'll add row 1. We're adding row 1. It's really like the elimination method, but with matrices. So change the sign there to a minus and adding that one. This one's staying the same. 1, 4, and a 13. So that by changing the sign there and adding that, you'll get a 0. Changing the sign there and adding that, you'll get a 9. Change the sign there, making it 23, and adding that, you'll get 36. I'll just put that little dot down there. Okay. Moving on. I want to get that to be a 1. So what I'm going to do now, the next little operation, I'm going to take that row here, row 2, and I'm just simply going to divide that by 9. And that now becomes 0, 1, and that becomes a 4. Now in this case here we could actually solve it. You know, I could just say here that of course this is going to be the, I should have written up, that's your A there, and that's your B there, and this is your number over here. So we can see that B equals 4. We could go back and solve it, but we're going to go through the process and work out the identity matrix. Now the next thing is, we'll just take this down here. And this guy is all right to the bottom, he's all fixed up. So we can work on the first row. Now what I'll do here, I want to change this by, I'll take row 1, okay, this row 1, and I will multiply row 2 by 4 and subtract, okay? So this is row 1, row 1, minus 4 times row 2. Okay, here we go. So, well, that won't have any effect, will it? If I'm multiplying that by 4, the 1 will stay as it is. But here, if I multiply that by 4 and subtract it, I'll get my 0. Here comes the identity matrix. So when I multiply that by 4, okay, which makes that minus 16, and 13 minus 16 is minus 3. Now we can just read off. We can see that is our A, that is our B, and this is our numbers. So we can see that A equals minus 3, therefore A equals minus 3, and B equals 4. Alright, and that's using the matrix method.